Welcome to Maths for You channel. A past question on pure mathematics from Oxford and Cambridge past paper. A curve has a parametric equations x equal t plus 2 over t and y equal t minus 2 over t, where t not equal 0. Find dy over dx in terms of t, giving your answer in its simplest form. Right, so x equal t plus 2 over t and y equal t minus 2 over t. So that x can be written like t plus 2 t to the power minus 1. The same thing here, t minus 2 times t to the power minus 1. So it's easy to understand how this differentiation works. Dx over dt is 1 plus 2 times minus 1 to the power t minus 2. That is the simplest form is 1 minus 2 over t squared. And again, dy over dt is 1 minus 2 times minus 1 times t to the power minus 2. That is 1 minus minus plus, so 1 plus 2 over t squared. Dy over dx, dy over dt times dt over dx. So 1 plus 2 over t squared, and that is dt over dx, therefore 1 over 1 minus 2 over t. So if you could find LCM t squared, for the first part is t squared plus 2 over t squared. Second part is when you do the LCM t squared minus 2 over t squared, and then when you flip over t squared over t squared minus 2. T squared cancelled out. What we left with is t squared plus 2 divided by t squared minus 2. That is the simplest form of dy over dx. Next part, explain why the curve has no stationary points. So at stationary points, always dy over dx equals 0. The gradient at any point of the curve, dy over dx is 0. It's 0 at turning point. Because of that, the tangent to the curve will be parallel to x-axis. So for that, we know that dy over dx, which is t squared plus 2 over t squared minus 2, equals 0. If you cross multiply it, it's t squared minus 2 times 0 is 0, so t squared plus 2 is 0. From that, t squared is minus 2, and t equal plus or minus square root of 2, minus 2. Which is imaginary. So t has no real roots, therefore no stationary point. Right, next part. By considering x plus y, or otherwise, just given us a hint, find a certain Cartesian equation of the curve, giving our answer in a form not involving fraction or brackets. So yeah, simplest form. Standard. Okay. But they actually gave us a hint of, start with this x plus y. We know this x equal this, and y equal this. So x plus y, when you add it, that 2 over t cancel out. So all we have 2t. So t equal x plus y over 2. So the whole idea is to eliminate t, Cartesian form. So x, go to the equation 1, x equal t, which is x plus y over 2, x plus y over 2, and 2 over x plus y over 2. So I just flip over x equal x plus y over 2 plus 2 times 2 is 4 over x plus y. LCM 2 times x plus y, then is x plus y squared plus 4 times 2. That is, if you just cross multiply as well, 2 times x plus y equal x plus y squared plus 8. And if you left hand side, 2x squared plus 2xy equal the right hand side, if you expand it, x squared plus 2xy plus y squared is a standard complete square when you expand it, plus 8. Then x squared is 2x squared. If you bring the x squared to left hand side, it will be just x squared. If you bring the 2xy to left hand side, that will be cancelled out. 2xy minus 2xy cancel out. And y squared, if you bring that to left hand side, will be minus y squared, and keep the 8 there. So that is the Cartesian form of x squared plus minus y squared equal 8. If it's x squared plus y squared equal 8, it will be a circle. But x squared minus y squared equal 8. You can stop it there. That's what they want. They want the simplest form, and no fraction or no brackets. So just x squared minus y squared equal 8 is the one. Thank you. Please subscribe the channel and share the contents with your friends and other fellow students. And as I said before in my previous some of the previous videos, send some question if you have any issues, and please send some comments if my the book through is slightly faster, slower. It just depends how the students look at it. If you feel that you need this either a particular video or question, you want it a bit more explanation, please send some comments, and I can do another video on that question. Go with slow. So you need to tell me how you feel and how you want it. I just sometimes miss one or two steps to speed up the process. But if you feel that you miss out, let me know. Thank you.